What is the kinetic molecular theory of gases? The kinetic molecular theory of gases describes gases as a collection of small particles in constant random motion. It explains their behavior based on assumptions about the motion, size, and interactions of these particles. How is absolute temperature defined based on Charles' law? According to Charles' law, the volume of gas is directly proportional to its absolute temperature. At constant pressure, the relationship can be expressed as V upon T is equal to constant. What is Avogadro's law? Avogadro's law states that equal volumes of gases at the same temperature and pressure contain an equal number of particles. This relationship allows us to determine the relative quantities of different gases in a chemical reaction. What is the ideal gas equation? The ideal gas equation is a mathematical relationship that combines the variables of pressure, volume, temperature, and the number of moles of gas. It is given by the equation PV is equal to nRT, where R is the ideal gas constant. What causes deviation from ideal gas behavior? Deviations from ideal gas behavior occur at high pressures or low temperatures. Real gases deviate from ideal gas behavior due to intermolecular forces, non-zero molecular volume, and other factors not considered in the ideal gas law. What is the van der Waals equation? The van der Waals equation is an improvement over the ideal gas equation that accounts for the deviations from ideal gas behavior. It incorporates correction terms for intermolecular forces and molecular volume. The equation is PV is equal to nRT. What is Dalton's law of partial pressure? Dalton's law of partial pressure states that in mixture of gases, the total pressure exerted is equal to sum of partial pressures of each individual gas. Each gas behaves as if it occupies the entire volume alone. What is Graham's law of diffusion and effusion pressure? Graham's law of diffusion states that rate of diffusion of a gas is inversely proportional to the square root of its molar mass. Graham's law of effusion applies the same principle to the rate of gas escape through a small hole. What is the process of liquefaction of gases? The liquefaction of gases is the process of cooling and compressing a gas to temperature and pressure at which it condenses into a liquid state. This process is achieved by reducing kinetic energy and increasing intermolecular forces between gas particles. What is the fourth state of matter? Plasma. Plasma is the fourth state of matter, distinct from solid, liquid, and gas. It consists of highly ionized gas, where atoms or molecules are stripped of their electrons, resulting in a mixture of free electrons and positively charged ions. How do temperature and pressure affect the behavior of gases? Temperature affects gas behavior by influencing average kinetic energy of gas particles. As temperature increases, kinetic energy and speed of gas molecules also increase. Pressure affects gas behavior by determining the frequency and force of molecular collisions. What is the relationship between volume and temperature for gases? According to Charles' law, the volume of a gas is directly proportional to its temperature when pressure is held constant. As temperature increases, the volume of a gas also increases and vice versa. How does molar mass of gas affect its diffusion and effusion rates? Gases with lower molar masses diffuse and effuse more quickly than gases with higher molar masses. This is because lighter gases have higher average speeds and therefore move faster through a given medium. How is gas behavior affected by intermolecular forces? Intermolecular forces influence gas behavior by causing deviations from ideal gas behavior. Gases with stronger intermolecular forces tend to deviate more significantly from ideal gas behavior and may exhibit condensation or liquefaction at lower temperatures. What are some examples of real-life applications of gas behavior and properties? Gas behavior and properties have numerous real-life applications. For example, the behavior of gases is crucial in the operation of internal combustion engines, understanding atmospheric phenomena, designing gas storage and transportation systems, and controlling the conditions in industrial processes like chemical reactions and fermentation. If you like this video, then please like, subscribe, comment and share our channel, Dr. Raza Academy and Educational Consultancy.